Hello everyone, I'm Sam Harwell. I'm the owner and lead developer here at Tunnel Vision Labs. In this video I'm going to give a brief overview of how you can get started using our GoWorks demonstration IDE. After downloading and extracting GoWorks, I'll have a directory like the following. I'll go into the bin folder. For Linux and Mac users, you've got a shell script that will launch it. For 32-bit Windows, you have GoWorks.exe, and I'm using 64-bit Windows, so I'll go ahead and launch GoWorks 64. So the first thing I'll do after I launch it is, for some reason, the NetBeans default formatting uses spaces, and that's not really the standard Go practice. So I will go to Preferences, and for the Go language, I'll say Don't use all languages settings, and I don't want to use spaces for tabs, and I only want my tabs to show 4 characters wide. You can go ahead and change font settings if you want, and I will choose a larger font so that it's actually visible on YouTube. And from there, it should be ready to use. So for the first example, I will use from the Tour of Go, sample number 1, just a Hello World program. And to get started, I will need to create the directory structure for this, and I'll call it, in my projects directory, Tour 1 is going to be my project for this sample, and for Go projects you always create a source folder. Inside of there you create your package. Hello is a good package for this project, and we need a Go file, main.go. This is going to be the main Go file for this project. I go back over to GoWorks and I can go File, Open Project. In my projects folder I can see that Tour 1 is showing with this black icon, and that means that it's recognized as a project. I click Open Project. After you open a project for the first time, you'll see this background scanning of projects. GoWorks is going through the entire Go standard library at this time to finish gathering any code completion information it needs. It doesn't take long, it's done now. And under source I can see the package hello. Main.go is my package, and I can go ahead and start typing my Hello World program. Now during this you're going to see at several points the code completion pop up. For now you can go ahead and ignore that. I will show you in a little bit exactly what it's trying to do and how I am hoping that it can help. And once we have it typed in, we will save it, and then we can build it. Building package hello, build successful, and we can go ahead and run. And we can see our output here, hello world, run successful, and it sure didn't take long. Alright, and so let's go for a little bit more of a complicated example. We'll close our Tour 1 program. We will jump back over to our projects folder, and for this one I am going to go through number 15, the numeric constants example. So for this one, reasonable name for our project is Tour 15, and we go through the same, create a source folder, create a package, and for your main package, this is actually going to end up being the name of your executable. So on the system, number is the package, number.exe is what it's going to create. I will create main.go here, which is going to be where I actually type my program. So I go back over to GoWorks, and I can go Open Project, Tour 15. Notice that currently in this version of GoWorks, if you double click it, it's going to actually try and take you into the folder. You need to click it, then you click Open Project. The next time I open a project, background scanning is going to go much faster. It's done. I will go into the number package main.go, and I will start typing in this program. Now when I'm typing this one, I'm going to give a little bit more overview of exactly what code completion is doing. When I type a letter, I don't have to type control space or anything like that. Code completion is going to pop up. I hit P, and then I hit space, and it completed that. Now here, I'm typing a declaration. Code completion is still going to pop up, and it's going to tell me that M, if I was to go on right now, M would be my declaration. So I'll type main, then I'll hit enter, enter. I for import, space. And then I can type, well, apparently I can't type. I'll type FMT. We're going to import the format package. Const C space, open parentheses. Here, big is our declaration. Equals 1, left shift by 100. Small is our declaration, equals B. Well, now it's already been declared, so big is, I type B, big is selected, I can hit space, right shift by 99, close parentheses, and go down. Now, our first function is needInt, F, well, function is highlighted, space, needInt, open parentheses, X is our argument, I for int, and you can see that it's selected, so I can close the parentheses, space, I for our return value, it's selected, space, open brace. Here's where it gets interesting. If I was to go R, it could be a declaration because I could go R colon equals 34. But what I actually wanted to do for this one is I wanted to return something. So I would go R. Now what it thinks at this point is I'm either going to have a declaration or maybe I'm typing real. What I'm actually after is return, so I'll type the E and the T, and you'll see that return is what it's narrowed it down to. At this point, if I hit space, well, it's going to use RET as a new declaration. But given the same thing, if I hit tab, it's going to fill in the item that was lightly selected in the bottom box. And this happens a lot. You'll get used to it. It doesn't take very long to realize the points where you actually need to hit tab, and it will do code completion where you want it, and it won't replace what you don't want. So I type return x times 10 plus 1. Our next function, need float. X is a float, and now I could be typing a function, and it's going to use that because in the past I typed very recently, just at the beginning of the line, I used the word function, so it's going to try and do it again. But to shorthand things, I can just type F64 because float 64 has F64 in that order. Close parentheses. Return value here is, of course, float 64. And I hit space and open brace. Here I can do exactly the same thing as before, but this time it learned from what I did before. When I type R, I was actually after return before. So return is what's going to be lightly selected immediately. At this point I can just hit tab. Then I can go x times 0.1, and I can go on. So we're going to go function main, and I'm going to go for the format package. I type fmt dot, now I'm going to type pln, trying to shorthand print line, and I can see that it selected f print line because it's got the P, the L, and the N. Well, that's not exactly what I wanted, so I'll hit the down arrow, and then I will hit the open parentheses. And then I can type needInt with just NINT, small, close parentheses, close parentheses. Well, once again you can see that it learned, because now if I type PLN again, it's not going to type fprintline, it actually is going to go for the one that we wanted. Now we need a float, NFL, small, close parentheses, close parentheses. Alright, FMT, PLN, we know it's going to do the right thing. Need FL, now we're going to type big. Well, it used bool, that's not what we wanted. But if we had typed the capital B, it would have selected it first. So either way, big. If I get it selected, I can go at any point that it's selected, close parentheses, and I'm done. I hit save. I can build my program, building package number. It's good. Run it, and run successful, and you can see that our output matches exactly what we would get if we were on this Tour of Go page and we hit run. As a final demonstration of the code completion features in GoWorks, I'm going to go back into GoWorks, but I'm going to go to the standard library, and I'm going to show you how it might have felt if this standard library method were being typed in GoWorks instead of in a plain text editor, whatever it was originally being typed in. I will use the same exact code as the method above, except instead of using shortened identifiers, I'm going to use full-length identifiers, and I will rename the method so that we don't have a collision. Destination and source, complete identifiers, same types. For I 0, I is less than len src. I still typed the shortened identifier, but it picked out source just fine. I plus plus. If, well, instead of x we're using block, but I can type blk dot OUU equals block dot out block dot b dot encrypt en block dot out block dot out block dot OUU equals 0. If block dot decrypt t, well, it's going to let me do a declaration just fine. srci dst equals src block dot out block dot OUU block dot out block dot OUU equals t.